Welcome back to another exciting day in mathematics. Warm-up number 16 is on the screen. Let's get started, please. We don't have a lot of time, so stay focused, please. I'm going to get through the lesson, believe it or not. And yes, you are going to have some home plate today. Let's go. That shouldn't take you more than about 5 minutes. All right. So I think we got it. So let me get my bell curve going. All right. So what did you get for the mean, Alex? 7. And have you got that? Also, standard deviation. What did you get for standard deviation? Bree? What? 3.29. Hands, have you got that? 3.2. Yes? All right. And who noticed that this is the same one as yesterday? So you're like, just got to crunching numbers. Yeah, I was trying to switch the slide and somehow, so anyways, I have 2 slides and I turned one on and turned one off. So this one stayed on and I forgot to turn the other one on instead of this. Anyways, you get the idea. So this is 3.71 and this is 10.29. So the normal range for our bell curve is from 3.71 all the way to 10.29. All right, copy the agenda for today. Warm-up number 16 is done. We're still focusing on statistics and probability. And your hopefully for tonight, it's on the slide, so you need to copy the Nearpod code that's coming up after this. And you're only doing numbers 1 through 16, evens, for tonight. Only. Thank you, Mr. Q. You're welcome. Yes, I got you. Evens. Yeah. All right. Okay, we good? All right. Copy the Nearpod code, ACTKZ. And in case you fall behind with the notes, because we're going to go pretty quick. We only have about half an hour, and we're going to crunch those 50 minutes into 30 minutes. So ACTKZ. And last night's home plate, you should have turned it in before the bell yesterday. Is that correct? Oh, yes. It was due at the end of the period. And tonight's home plate is these. So once again, you need your Nearpod code. Yes. No. All right, get a Cornell note ready, please. I can classify qualitative and quantitative statistics. I can classify qualitative and quantitative statistics. We don't need a fair model today. Okay. Copy that really quick. So, today we're revisiting qualitative and quantitative statistics. You're like, it sounds kind of familiar, Mr. Q, but it doesn't. Yeah, we already introduced this smoothly at the beginning of the school year, and I've been touching on this every week. Today we're going to solidize these two, and here it goes. Look up to the screen. First of all, what are statistics? Tell your neighbor, please. By now they should know the definition. Yes, the science of collecting, summarizing, analyzing data, but what is the key word at the end? Concluding, conclusions. You need to come up with conclusions at the end. Last call on those laptops, Chromebooks, so I'm going to take them away, and your pods, put them away, please. Y'all ready? So we know that. Next, here we go. I introduced at the beginning of the school year, the first week, data. Is that correct? And we said there's categorical and quantitative. Tell your neighbor the difference between one to the other. Difference between one to the other. All right, Angel said he's got it. Categorical, Angel. No numbers. Quantitative has numbers. That is correct. So categorical cannot be expressed with quantities or numbers. Quantitative with numbers. However, today's objective talked about qualitative and quantitative. So we know that quantitative are these. That means that this one, instead of calling categorical, the other name is qualitative. Qualitative. Okay? So, however, today we're going to focus on variables for quantitative. Quantitative variables for quantitative data. All right? So here we go. There's two types, discrete and continuous. So write quantitative, and then underneath write discrete and continuous. Discrete and continuous. So what's the difference between quantitative, discrete variables? Well, discrete can be counted. Counted. Can be counted, and in parentheses write exact or exact amounts. All right, so once again, today we're focusing on quantitative data, and the variables for those are discrete or continuous. And what's continuous, Mr. Q? Well, if discrete can be counted, what would be continuous? Cannot be counted. Cannot be counted. Or in other words, not exact. So I'm going to start a little slow, but like I said, this lesson's going to go super fast like this. Oh, that was fast, right? All right. So here we go. Discrete versus continuous. Ready? Example 1. Don't copy this. Look up. Writing utensils down. And it reads, number of hours a week teenagers spend on social media. Think about it. If we were to gather data, number of hours a week teenagers spend on social media. Say, neighbor, that's discrete or continuous. Be careful with this one. So let me ask you a question. Let's say Noel only spends 1 hour a week on social media, compared to Brianna. She's probably like 5 hours on social media a week. And then I go to Alyssa, and I don't know. I need to go with each one, but do I know exactly what each one's going to have? No. So since we don't know and it varies, that becomes continuous data, because it's not exact. Now, will some people not tell me the exact amount that they're spending on social media? Unless I got their electronic devices and did a quick analysis of the data. Is that correct? They're like, oh. So copy that one, please. Example number 1. Number of hours a week teenagers spend on social media. So underline continuous or write continuous, because times vary from teen to teen. Nah, you probably don't spend a lot of time on social media. You guys are good. again, number of hours a week teenagers spend on social media. It's continuous because times vary. Is it vary with a Y, right? Not bad. Sorry. Vary from team to team. All right. Let's do another one just to clarify. Okay, here it goes. Once again, you have the nearpod code in case you fall behind. Here we go. Example 1Q. Number of touchdowns Royce Freeman scored while attending IHS. Tell your neighbor what kind of data that would be. Bernard, what do you think? Why discrete? Yeah, because the number of touchdowns scored, they're already there. All you have to do is go to the records and get them. Does it vary? No. We know exactly what he got. Don't copy this one. Let's go to the next one. And this is discrete. Oh, you want to copy it, Alex? Wow. You know what? Copy this one, everyone. Example 1Q. Thank you, Alex. Thank you. And this is discrete, and then just write why it was discrete underneath, please. Thank you. All right. Everybody got that? Yes? All right. Everybody say thank you, Alex. Thank you, Alex. Yay. Let's go to the next one. Example 1 Super Q. It says, the amount of money someone earns working a 40-hour a week at a gas station that pays minimum wage in California. So you neighbor, which kind of variable is it, discrete or continuous, and why? Which one is it? All right. Good discussions. What do you think, Jenny? Discrete. Hands if you agree with discrete. And why is that, everyone? Because number one, there is a total of 40, and we know how much the minimum wage is where? In California. So therefore, it's exact. Yes? Don't copy that one. Or what do you think, Alex? What do you think? Say yes or no. Okay. Woo, nice save. Let's go to example 1 mega Q. It reads, the weights of high school athletes in Imperial Valley this past 22-23 school year. Talk it over your neighbor. Is it discrete or continuous? Uh-huh. Good discussions. Let's see. Let's take a quick poll. Who says discrete? Who says continuous? Yeah, I'll go with continuous just because it fluctuates on the weight. However, check this out. I want to use this example as an example where statisticians or people that gather data, they disagree. For example, if I was a statistician that didn't agree with the majority, I would say, well, do I know who the athletes in Imperial Valley are? Yes, because I can go to each school, get the list. And then from there, could I get the weights as they were being weighed that day? Yes. So what can I conclude? Me, I would say it's discrete. However, what would be your counter argument? Who would give me a counter argument? Alec. So the weight of every high schooler isn't the same, and it can fluctuate maybe for the day. Maybe the day before you went to burrito, got yourself a California burrito, right? Have you guys tried those? No? Carne asada? No? Anyways. So yeah, I'll go with continuous on this one. Okay? Do we copy that, Alex? All right. So from 1 to 5, how comfortable are you with discrete and continuous? 5, 4, 5, 3, yeah, we got this, right? All right. So we talked about two types of data, qualitative, quantitative. We're focusing today on quantitative data, but the variables are discrete and continuous. So once we have those variables, we can actually classify them, which means give them a different name for each. So classification could be done by the different type of category for each variable. Now there's 4 different types of categories. Copy this Freire model, please. Classification or variable classification, there's 4 of them: nominal, ordinal, interval, and ratio. Nominal, ordinal, interval, and ratio. All right, so nominal, ordinal, interval, and ratio. Nominal comes from the Latin word nomina. They use that as a list or kind of like an attendance list. However, many times when they do the nominal list, they just start with the person that they see. So I would write Eric first, and then from there I would go Mia, and then from there Samantha, and then Ethan Aguirre, and then Ethan Reeves, and then no order in particular, just sending a list. That's why the definition for nominal is the list of data without any particular order or ranking. List of data without any particular order or ranking. List of data without any particular order or ranking. And sometimes that could also be used on a daily basis. I can tell you that my wife, she likes making lists every day of tasks that she needs to complete. She likes doing those lists. I don't know. Me, I'm more of a, I already have like a certain plan, and for my personal list, I have it in here. So, you know, there you go. All right, questions with nominal. Straightforward? All right, so check this out. Nominal, look what this one is called. Ordinal. Alex in the house, write that down. List of data with a particular order or ranking. Man, you guys remind me of being kindergarten. List of data with a particular order or ranking. So yeah, so if nominal, you just list. Ordinal, you can say, now that I have all the names, I'm going to list them in alphabetical order. So you start, you know, from A to Z. Okay? So once again, nominal, you just collect the different names. Ordinal, you organize them by alphabetical order. So that's ordinal. However, check this out. Even though you organize them by alphabetical order, does that mean that one person is greater than the other in the order? No. It's just organized by what? Alphabetical order. Once again, is one more valuable than the other? No. There's no particular value from one to the other. With that said, interval. Interval, going from one to the other, is a list of data with a particular order and ranking, however, with precise differences between the ranks. This one does have precise differences or ranking differences. Yeah, this one requires precision from one to the other. Kind of like this. If I was to ask you to go on YouTube and see the weather forecast for August in Imperial Valley by city, any particular day, you're going to go, you're going to see that Imperial was at 118 one day, but then El Centro was at 119, maybe 1 degree over. Do you think that 1 degree makes a difference? Oh, yeah, especially when it's getting hotter, right? Or imagine this, you're out doing whatever activity out in the sun and it's 119 degrees, and then they tell you it's going to go up to 121 today. Does that make a difference? Yeah, so that means when you list the temperatures and you list them from degrees, they have a specific and precise difference from rank to rank. Does that make sense? Yes, I see you. All right, good. And last but not least, ratio. Ratio is basically all of this, but at the end you can use ratios with numbers. And what's another word for ratio? That you can create fractions or decimals comparing the different amounts. Everybody got it? Yes? All right, so these are the 4 different types of classifications for variables. And once again, we're still looking at discrete and continuous, but within those, we have these 4 different classifications. So let me give you some examples. Don't copy this, writing utensils down, look up to the screen. So I already mentioned for each of those, but here goes one more time to make sure we got it. Nominal level data can be classified like this. What if I ask for zip codes of all your contacts, like all your family, friends, acquaintances? Some live in San Diego, some live in LA, Riverside. So there's different zip codes. So here in the valley, let's say here in Imperial 92251, San Diego 92021, Hollywood 90210, East LA 90210, 90. No, my bad. East LA is 90210. Where's that Hollywood? Oh, Hollywood, yeah. And East LA is 90201. So 90201 is East LA. Riverside, we got 92335, something like that area. So anyways, when I collect all that data, do any of them have a specific value? No, you just list them, and there you go. Same thing with when you're listing different gender, eye color, political affiliation, religious affiliation, major field of study, mathematics, let's go, computers, and so on, nationality. No particular specific greater than the other. You're just listing stuff. Ordinal. A, B, C, D, F. Why? Because it's in alphabetical order. Judging, such as first, second, third place, you got to have that. Ranking, such as poor, good, excellent, such as some of the work that you guys turn in. And tennis players ranking. No, I'm just like, no, not you guys, like some students, yeah. Interval level, SAT scores, doesn't matter how much you score. Therefore, for each interval, it has a specific value. So make sure you remember that. Temperature also, specific value from 121 to 119. 1 year, I think, here in the valley went to 123, 1 year, so 25, yeah. I remember 123 because I was working outside. I was installing, before I came to teaching, I used to install, I'm a electronic tech, so I got certificated to do all kinds of stuff on cars. But my boss didn't get us a shade, so I was doing installations outside in the sun, 123 degrees. Woo! But I was young, like you guys, so got some Gatorade, and that was good. And ratio. Notice height, weight, time, salary, age. What can we represent with those? Using what? Numbers. And can we do fractions and decimals? Yes. All right. So here we go. Just to solidize this before we move on to some examples, here we go. Nominal. Here are some basketball players. James Harden, Curry, James, Jordan, Nikola. Now, are there any particular order? No, I just gathered the names, and it's just a list. Now, look at the ordinal. Tell your neighbor, what was the order, please? What was the order? Anyways. See, Noel, what was the order? He said alphabetical. J, L, M, N, S. Yes, alphabetical. Because for ordinal, there's no one greater than the other. It's just an order. Now, interval, there is one greater than the other. Let's go. Greatest to the least greatest. Yeah, there was an argument earlier that they were like, Mr. Q, can you just send James Harden to the end? I'm like, we'll just leave it like that for right now. And let's go to the next one, ratio. How much each one of them bench presses? Michael Jordan, 345. LeBron James, 230. James Harden, 150. 115 and 105. That's their bench press. Now, question. Can I make fractions comparing them to Michael Jordan? Yeah, 230 over 345. Yes, or 105 over 345, and so on and so forth. Okay? So, with that said, now that we got clear as to what each one is, let's go to example number one. Example one. If I was to gather this information, tell your neighbor what kind of variable classification that would be. Talk to your neighbor, let them know why you're choosing that one. All right. Let's see, Priscilla, what did you choose? Which one? I couldn't hear. Which one did you choose? Ordinal. Be nice. Whoa. Ordinal. Hands if you go with ordinal. Okay. Why did you go with ordinal, Priscilla? Small to big. Okay. With no greater value, you just ordinalize. Okay. Who said nominal? How about interval? Why interval, Alex? The what? Okay, so interval because of price. Okay. So why am I presenting this like this? Because I didn't give you a reason to organize this and to classify it. I just gave you that. So which means that depending on which area you're going to choose, it's going to be the classification. So Priscilla chose just to organize it from the small size to the big size. That's ordinal. But if you were going with the price, then that means from the least to the greatest. That's interval. And one last one before we leave. Look up to the screen. One last one. Tell your neighbor the classification for that one. Some of you said nominal because of the color. How about interval because of the sports cars versus little shoe cars or whatever? Anyways, all right. So with that said, guys, once again, your home place for tonight, numbers 1 through 16 evens. Have a good one, guys. See you guys tomorrow. Bye.